Hello, good evening everyone. I am going to discuss about arithmetic logical unit. Okay, please go through this lecture. If you are having any doubt in the arithmetic logical unit, please make a call and ask. And also I am going to discuss about multiplier. If you are having any doubt in the multiplier also, you may make a call and you may ask. Is it clear? Okay, now come back to the concept. Let's start with ALU. Okay, ALU is nothing but arithmetic and logical unit. It consists of two parts, arithmetic part and logical part. These two parts must be considered as a single unit. This represents ALU. Is it clear? Now to explain ALU in your VLSI, I am going to choose 4:1 multiplexer. Let us consider this is a 4:1 multiplexer. Let us assume this is a 4:1 multiplexer. It consists of two selection lines, S1 and S0. It consists of 4 inputs and only one output is going to be allowed. Now let's check S1, S0 and Y. Now if you observe that since it consists of 4 inputs, you may have two selection lines. You should have 4 combinations, 0, 0, 0, 1, 1, 0 and 1, 1 combination. Okay, for each and every combination you required one of the input as Y. Okay, now you have to design in such a fashion. Let us assume this is a half adder, this is half subtractor, and this is under logic, and this is OR logic. And the output of half adder I am considering only sum. Okay, I am not considering carry. The output of half subtractor I am considering only difference. I am not considering borrow. This is output of AND gate. This is output of OR gate. Now you know very clearly that based on the selection lines, if 0, 0 is selected, sum is considered. Are you clear? If 0, 1 is considered, difference is selected. If 1, 0 is considered, AND logic is selected. If 1, 1 is considered, OR logic is selected. Is it clear? That's it guys. This is ALU in your VLSI. You have to write this concept if ALU is asked in your question. Is it okay? Now coming to the multiplier. Okay. Now coming to the multiplier. They will ask any multiplier in the VLSI. Basic multiplier I am considering, and this may be also called as array multiplier. Okay, now you have to see, let us observe very carefully. I am going to talk about 4-bit multiplier. 4-bit multiplier. Okay, 4-bit multiply. Now we know that A and B are the two inputs. These inputs consist of 4 bits, A3, A2, A1, A0. This is B3, B2, B1 and B0. Okay, now you know that from the lower classes onwards, first of all we have to multiply B0 with each and every bit of A, and B1, after that B2, after that B3. Okay, similarly I am going to multiply this. Observe very carefully. Now you are having A3, A2, A1, A0 into B3, B2, B1, B0. Okay, now I am going to multiply. See, observe very carefully. A0 into B0. First I am considering this. A1 into B0. A2 into B0. A3 into B0. After that, A0 into B1. A1 into B1. A2 into B1, A3 into B1. After that, A0 into B2, A1 into B2, A2 into B2, A3 into B2. After that, A0 into B3, A1 into B3, A2 into B3, and here I don't have any space, that's why I am writing here A3 into B3. Now if you observe that how many partial products are there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Because it is 4 bit, therefore 4 into 4, 16 partial products are there. Okay, how many partial products means 16 partial product. How many final product means you should add these two, 4 plus 4, 8 final product. Okay, now these all are I'm going to consider as dot representation for easy explanation. Now observe very carefully, guys. Okay, now this each and everything I'm considering as a dot. Okay, dot represents partial product. Observe very carefully. You are having 1 2 3 4, 1 2 3 4, 1 2 3 4. Next, if you observe that 1 2 3 4. Now this maybe directly comes these two. You required half adder for this. I'm considering half adder. The sum is taken like this and the carry is considered like this. For that I'm considering full adder. These three, full adder. The sum is taken like this and the carry is taken like this. And these two, half adder. The sum is taken like this and the carry is taken like this. And if you observe that full adder, the sum is taken like this, the carry is taken like this. And once again full adder. Is it clear? Full adder, the sum is taken like this, the carry is taken like this. Now you require half adder. Okay, observe here, half adder, the sum is considered like this, the carry is considered like this. Here if you observe full adders, these three will be considered as full adder and the sum is taken like this, carry is taken like this. And these three is considered as full adder, the sum is taken like this, the carry is taken like this. And these two, don't forget, this one and this one is considered as half adder, the sum is considered like this, the carry is considered like this. Now if you observe that here, these three is considered as full adder, the sum is considered here and the carry is considered here. And these three again considered as full adder, the sum is here, the carry is here. And these three considered as full adder, the sum is here, finally the carry is here. Now if you observe that this is P0, P1, P2, P3, P4, P5, P6, P7. From P0 to P7, this is the final result. Okay, in this manner you have to design a array multiplier. Is it clear? Okay, just I will give some of the hint to you. Okay, let's observe very carefully. Half adder, full adder, you have to take these bits and the sum is taken directly. Half adder, this may be full adder. Okay, this carry will come here and this may be some, like that you have to design. I hope that are you clear. Full adder, you have to consider 3 bits, this one, okay, and one extra. Here in this manner you have to consider. Just go through the material. If you are having any doubt, you may ask. Is it okay? Thank you very much for each and everyone. Okay, in the adders, if you go through the material, if you are having any doubt in the adders, you may ask, guys. Is it clear, all of you? Thank you very much. Have a nice day.